It is not the end of the year. It's April. I knew what you meant. We get out like in June. It's April. It's still in June. Last time I looked, June the 1st. It's in June. Suck it up, Buttercup. You're still out of school. To put things in... I'm sorry? Interesting you would say that. Let's put it in perspective. In 3 weeks from today, you will be taking your STAR EOC. 3 weeks from today, you'll be taking the STAR end of course exam. Okay? The week after that, you'll be taking the reading tests. The week after that, you'll be taking the reading tests. Okay? 7th graders, you take it on a Tuesday. 8th graders, you take it on a Thursday. Okay? Any questions on that? All right, so here's the thing. We're almost at the end of the unit. We have solving and interpreting quadratics today. Tomorrow we have applications. Applications is basically word problems. And I'm not here, so video. I've already recorded the video. I recorded it this morning. I dressed up for it, so you'll notice I look really good whenever I'm doing the video. Very good. I'm glad you said that. I was wondering who has actually seen the videos. So I know Joey has. The rest of you, I don't think you have. Okay, good. Okay, so it doesn't matter if I dressed up. I actually wore like my pajamas and a funny hat. So I don't know if you can tell. So I've recorded that. You'll do that tomorrow. I would definitely kind of pay attention. Tomorrow might be a day. So Brady, you're the video, like Lord of the video. So if you need Brady to rewind the video a little bit, because you need to make sure you're hearing everything. Muy importante. Okay? And then after that, we do the CMS assessment on Thursday before you head off for your 3-day weekend. That CMS assessment, the best way to study for it is everything in your packet up until day 10. That's it. Know how to do everything. Today is a day where we kind of package everything and put it all together. So here's my question to you. Without graphing, describe everything you know about the graph of each of the equations below. Let's start with equation numero uno. Kaylee, tell me one thing we know. It opens up. Very good. We know it opens up. Cade, tell me another thing. It is more narrow than the parent function because our a value. Colin, what do you see? Y-intercept is -5. Where it crosses the y-axis is -5. Ethan?
It is off the y-axis.
What is off the y-axis? The vertex is off the y-axis. We know that because we have a b value. We know it's off the y-axis. Okay? How would we write the range for this particular quadratic? How would I write the range of this particular quadratic? The range. Y's that are greater than or equal to. How do we know that? Because the range is based off of the vertex, and all y values must be greater than that vertex. So the range would be all y values greater than or equal to some y value of the vertex. Could we find the vertex? Yeah, what's the first way we would try to find the vertex? Plug it in. No. Calculator, go to the table and look for what? Do what, Carden? Symmetry. Plug it in, go to the table, look for symmetry about the y's, find the vertex. How many vertices can you have? One and only one. So if you look at a table, peeps, and you see like 3, 0, 0, 3, Joey, what do we know? We know the vertex is here. So you find what the x value of the vertex is, which, Avery, you could use negative b over 2 times a if you need to, and then you find the y value as well. Everybody good? Questions? All righty. Riley, tell me one thing we know. It faces down. Thank you. Madison. The vertex is on the y-axis. Cardin? No, go ahead. It's more wide than the parent function. In fact, it probably actually looks more like this, right? Avery, D. Already got that. Yes. Kiana? That's the vertex and the y-intercept. Remember, if it's not off the y-axis, then both the vertex and the y-intercept are the same place, right? So keep that in mind. We know, very good, Kiana, we know both the vertex and the y-intercept, right? The range would be all y values less than or equal to what? Negative, 9. We know the range. Has to be. That is the y value of the vertex. So be careful about giving me some like spewed fork. You need to be thinking. I need you thinking. Any questions on that? Good to go? All right, so let's jump into today. Here we go. What does it mean to solve a quadratic? What do I mean when I say solve the following quadratic? What do I mean? What am I looking for? Yes, ma'am, go ahead. There are a lot of x's on a quadratic. There are a lot of x's. In fact, there are an infinite number of x's, so it can't be what the x is. More specifically, I know what you mean. What does that mean? Hold. You said find the roots. What does that mean? You find the x-intercepts. When I say solve a quadratic, I want you to find the x-intercepts. When I say solve a quadratic, I want you to find the x-intercepts. I want you to find where that thing crosses the x-axis. Before you do anything else with a quadratic, what should you do? Madison, stop mumbling. Tell me. No. It's the first thing you should do to a quadratic. Set it equal to 0. Set it equal to 0 and put it in standard form. Guys, you can't tell me anything about a quadratic. You can't tell me about solutions, factors, vertex, axis of symmetry, range, domain. You can tell me nothing until it's standard form equal to 0. Okay? That's kind of where you need to begin kind of getting your heads. I want you to get it in standard form equal to 0, and then you have this library of information in your heads that you can kind of draw from. I'm going to come back to the video in just a second, okay? Or I guess we just do it now. Let's see if it does it. Sometimes it hasn't been working. It goes to, yeah, you say that. It's like it works, but it has no sound, so I end up having to flip it over into Google Chrome. See? No sound. So, no, I have no patience whatsoever, so I just do these and these and hold and these. I always wondered what's happening on the video when this happens, though. Ooh, it sounds epic. Thank you. Ooh. That you got right. Yeah, no thank you. Oh, there it is. Ooh. Ooh, math. First I was like, how's he going to curve back up? But then I realized he's on a bungee cord. That's like the greatest rainbow ever. Uh-huh. Okay, so now the worst is when I'm recording and I end up with like something like terribly gross or inappropriate when that happens. Hold, let's get music back on, and let's get into what we're going to do today. So here's what I want you to do. Number one on your notes. Here we go. I have a quadratic. Is it in standard form? It is in standard form, therefore we can go forward. How would we find the vertex and what is it? Yanni? Tristan, you have an answer today. Tell me. Shh. Huh? It is 0, 9 because we have no b value, so the y-intercept is the same as the vertex. Vertex is at 0, 9. Making the axis of symmetry what? X equals the x value of the vertex. We're going to do some reminders. We haven't done this in a couple of weeks. The y-intercept matches the vertex in this case. The range would be all y values that are less than or equal to, because it faces down, so less than or equal to 9. Now we're going to solve it using the square root method. By the way, you need to know how to use all 4 methods. The square root method said we're going to set it equal to 0, so we make the output 0, so we have 0 equals negative 1/4 x squared plus 9. What we want to do when you're solving the square root method, you want the x squared guy on one side and your constant on the other. So I'm actually going to add 1/4 x squared to both sides, which gives me 1/4 x squared equals positive 9. What would I now do to start to get the x by itself? There's a lot of mumbling. I'm sorry? Nope. Guys, if you don't understand the rules of order of operations, when you solve an equation, you're going backwards. That's why we always add or subtract the constant first. So before we get to exponents, we need to do multiplication division. So we would divide both sides by 1/4. Now before you rush off and think that you have all crazy good math skills, what is 9 divided by 1/4? 9 divided by, what's the rule when you divide by a fraction? What's the other thing you can do? Multiply by its inverse, right? So what do you think 9 divided by 1/4 is? Very good, Brady. It's 36. It is 36. And now we can square root both sides since it's called the square root method. And what's the square root of 36? It is plus or minus 6, and if you told me it was 6, you are wrong. Every square root has 2 answers except for the square root of 0. The coordinates of the x-intercepts, how do we write them as ordered pairs? What value has to be 0 for an x-intercept? The y. So we would write them as negative 6, 0, and 6, 0. Make certain you do not make that silly mistake on a test. Any questions? Let's try these. 3x squared plus 2x minus 5. What's the vertex? Pick up your calculators, plug it in, hit graph, see if we have symmetry, please. Trace x squared plus 2x. By the way, the minute you see that it's off the y-axis, that's where you're going to go. And you go to your calculator and you're looking for symmetry. Anybody see symmetry? No, I don't either. If we don't see symmetry, what's our next step? Negative, very good. Negative b over 2 times a, which in this case is negative 2 over 2 times 3, which simplifies to negative 1/3. Our vertex is located at negative 1/3 something. I go to second window. I type in negative 1 divided by 3. I go back to my table. I arrow up. Negative 2 over 6. Hold. Negative b over 2 times a. Negative b over 2 times a. Is that right? Oh, never mind. Negative 1 divided by 3. Okay, when you arrow up, do you see symmetry? I do too. That means my y value is negative 5 1/3. You notice how it's 0.3 repeating. Know what decimals turn into fractions. Okay? Any questions on how to find that vertex? Now we're off and running. Our axis of symmetry. X equals negative 1/3. It's the line. It's that vertical line. The y-intercept is what? 0, negative 5, because the y-intercept is your c value. And the range would be all y values greater than or equal to negative 5 1/3. Any questions at all about how to solve that one? Then please go ahead and solve it using factoring. I want you to solve that quadratic, the original quadratic, using factoring. I want you to find the factors, then use the zero product property rule to find the zeros. Give you about 30 more seconds. Now remember, when you factor, the very first thing you do is make sure it's equal to 0. A times c. You're looking for the factors of a times c that add up to b. Make sure you're being careful about the value of your b. Especially when you're finding like one negative and one positive number, make sure you get it right on which one's the negative and which one's the positive. In this case, I ended up with negative 3 and 5. Because negative 3 times 5 is negative 15, and negative 3 plus 5 is positive 2, which is what I needed. Now, I still used the the grouping. I just use grouping because drawing the box is the thing. But if you still use the box, box away. But I'm going to do negative 3x and positive 5x and put them right here. So what I end up with is 3x squared minus 3x plus 5x minus 5. I just substituted in the two x values I found for the b value. And then we split it down the middle. What's the GCF of my first? 3x times x minus 1. I move the x minus 1 over here, which makes this positive 5, which means my factors are 3x plus 5 and x minus 1, and that is all equal to 0. Any questions about how I got those? Now you set each piece equal to 0, and you would solve for x. So that means my x is negative 5/3 and positive 1. Those are my solutions, my roots. Those are my guys. And if I write them as x-intercepts, it would be negative 5/3, 0, and 1, 0, because the y value is 0. Now, what I mean, y'all all put it in your calculator right at the beginning, yes? Hit the graph button real quick and tell me if it looks like Your x-intercepts are at negative 5/3, which is negative 1 2/3, and positive 1. Is that what it looks like they are? Yeah. It's a very quick way to check and make sure you're right. Okay? Because if you hit graph, that's where they should cross. So here's what you got today, guys. You got 30 minutes. You got a classwork and a homework. The homework is only 2 problems, which means I want the classwork done, then I want the homework done. Make sure you check your keys in between. Tomorrow, if y'all run into problems, I will be able to step out of my meeting if y'all need me. Just give me a holler, okay? Not if there's like a lockdown, because, you know, theoretically you're not supposed to be on your phones. Joey?
Oh, I wasn't.
You were on your phone.
Hey, but you texted me.
That is an excellent point, but I was not in lockdown. I was at OU drinking coffee.